This is Srikanth, working as assistant professor in electrical department. Now we have one more topic on network topology or graph theory, that is analysis. So which analysis we have? So three matrices, that incident matrix, basic tie-set matrix, basic cut-set matrix. We will check it one by one now. For network topology, we have three analyses. Those are incident matrix, basic tie-set matrix, and basic cut-set matrix. So we have three analyses. Here, basic tie-set matrix is nothing but your like mesh analysis, and basic cut-set matrix is nothing but your like nodal analysis. Okay, so tie-set, cut-set matrix, and incident matrix is your basic matrix. So you can get like Kirchhoff's law, Kirchhoff's current law. You can say like Kirchhoff's current law. Okay, so these are some matrix. You can find out those branch current, nodal voltages. Okay, branch currents are node voltages. So here we have like first one is incident matrix. So incident matrix is nothing but A matrix. You can say like a with the letter A, and basic tie-set matrix is we have like B, and cut-set is C. So A, B, C matrix we have, and before moving to this matrices, we need to know the original graph. So circuit to original graph. We already discussed in previous video. You can check my previous videos. In that we have how to draw the circuit to original graph. Okay, so after that original graph, using that original graph, you can draw the matrices A matrix, B matrix, C matrix. So after original graph, so first we have the circuit to graph, graph to original graph. So original graph to we have A, B, C matrices. Now first one is incident matrix. That matrix is number of nodes into branches. Number of nodes. So how many number of nodes we have into the branches? So that is incident matrix. And cut-set matrix is, so we have the trees. So trees into branches. So number of trees into branches. And tie-set matrix is number of links into branches. Links is nothing but your co-trees. Okay, so branch is common, but number of nodes for incident matrix and number of links for tie-set matrix, number of trees for cut-set matrix. Just remember those values. Okay, so N into B is A matrix, L into B is B matrix, T into B is your C matrix. And from original graph, we have nodes and branches, as well as some trees and co-trees. Okay, so here we have directions also. Directions. So any directions. I have different directions. So suppose I want to write like A matrix. For A matrix, we need to use number of nodes. Nodes means 1, 2, 3, 4 nodes. So 4 nodes. And branches, here for this graph, nodes are 4, branches are 5. Okay, so for this graph, your A matrix is 4 into 5. And B matrix is number of links. So how many links we have? 1, 2 links. So 2 into 5 matrix. And cut-set matrix is trees. So 3 trees we have, 3 into 5. So this is like A, B, C matrix basics. So we need to know the number of nodes, number of links, and number of trees. So using nodes, so how will get like A matrix, and using links, how will get like B matrix. Using tie sets, so trees, how will get like cut-set matrix, And moreover, here we need to follow the directions. So direction is very important for A, B, C matrices. So every matrix, so A matrix or B matrix, C matrix, so there we have some rules, but that rules is depending upon your directions. So direction, your own wish, no problem for the direction. You can give any type of direction like a forward bias or reverse bias, but there, which directions we have, the directions value will be come to your matrices. Now here, incoming current. So suppose I am taking like one node or one loop or one particular cut set. So here we have the tie set means loop, mesh analysis is nothing but your loop, and cut set is nodes. So where you want to cut their value. Okay, so that place, which place you want to find out the values means the incoming values. So here suppose at one node, for this original graph, at one node I want to find out some values, different values. The values is depending upon your directions. So the direction is here incoming are. So incomings are plus 1, we need to consider. Outgoings are 0. Suppose this is minus 1. Suppose A, B, C, D, E is my branches. So C branch current is incoming and A branch current is outgoing. So incoming are plus 1 and outgoings are minus 1. And what about B, D, C? So we don't have B, D, C. So B value is 0 and D value is 0 and E value is 0. Okay, we have only two branches. So A and C. So A is incoming plus 1. Sorry, C is incoming plus 1 and A is outgoing minus 1. That's it. Up to that, we need to give the values. And remaining branches. So the remaining branches are not connected. So we need to give the values also for that. That values are zeros. So which branch is not connected, those values are 0, and which branch is connected. So incomings are plus 1, outgoings are minus 1. Okay guys, so just remember those things. Here we have like post plus minus 0. These 3 are will get in matrix. So any matrix, so A, B, C. So these 3 matrix depending upon zeros and ones. So 0 and minus 1 and plus 1. So these 3 values come in this matrix. So plus 1 means when we have the same direction. So which value you want to take. So at node or at loop or at a cut set. So where you want to take that value depending upon the incoming values are plus 1 and outgoing values are minus 1. And we don't have any branches there. So we have like 0 values. So this is about some basics to find out those A, B, C matrices. Okay guys. Now we are moving to like a matrix. So incident matrix. So A matrix. It's like Kirchhoff's current law. If you know the Kirchhoff's current law, it's very simple. So what is the Kirchhoff current law? At a particular junction, incoming currents are equal to outgoing currents. You can say like that also. A particular node, incoming currents are equal to outgoing currents. Okay. So suppose at node we have like A branch here. Suppose this is my circuit graph. Here I have the A branch. So compared to between 1 and 2, we have the A branch. So for 1 we have the minus 1, 2 we have the plus 1. Am I right? At one node, it's like outgoing. We have the minus 1 value. At 2 node, it's incoming. So if you add the branch value, plus and minus will get like 0. Okay, between 1 and 2, if you want to add the branch value, we will have a 0 value. We'll check it now. Okay, no problem. Okay. Here, A matrix is N into B, number of nodes into branches. So number of nodes into branches. So for any circuit, we need to draw the graph with directed graph. So we require the directions also. Okay, and that branch, how many branches we have? So circuit branches not equal to your graph branches. Why means in circuit you have the currents. So if you have the current source, it's a like open line. So we have different values. If you have two current source in circuit, we'll get like -2 branches compared to circuit. Okay, and number of nodes is fixed for circuit to graph. So if you know the number of nodes and branches with direction, so we'll get a matrix very simple. Like no need to go worry about the trees and links. So trees are useful for cut set matrix, links. Co-trees are useful for die-set matrix. Here no need to worry about the tree and co-tree. Okay, if you know number of branches and nodes with direction, branch direction also, then we will get the A matrix. Very simple. And here I have one circuit. So from this circuit we have 1, 2, 3, 4, 5, 6. 6 branches we have. So 6 branches and 4 nodes we have. So from this circuit to graph we know how to draw. So 1, 2, 3, 4 nodes. So 1, 2, 3, 4 nodes, and 192 have the resistor, 192 have the one line, and 2 and 3 have the resistor, 2 and 3 have the one line, and 193 have the resistor. So 193 have the line, and 2 and 4 have the resistor. So 2 and 4 have the line, and 194 it's a voltage source. So voltage source need to short circuit. So short circuit. And 4 and 3 have again one more voltage source. It's also short circuit. And give the direction. So which direction you want to follow? So you can follow any direction. You can follow any direction. No problem for the directions. So at the end result is we'll get the same answer. Okay. So here we are finding the A, B, C matrices. That's it. Okay. So we are finding the A, B, C matrices. So for A matrix, we require number of nodes into branches. So for this circuit to graph, we have the directed graph. So the direction for each branch. And now I want to write the matrices. So for that A matrix, number of nodes. So how many nodes we have? N1, N2, N3 and N4. So we have 4 nodes. Then branches. How many branches we have? So A, B, C, D, E, F. So A, B, C, D, E, F. So we have the branches. Now at particular node, I want to find out the values of each branch. So at node, at N1, this is like N1, N2, N3 and N4. At N1, so how many branches we have? A branch, F branch and C branch. Just write the values for A branch, C branch and F branch. So we have the values for A, C and F. What about remaining? So remaining are not connected. So those are values are 0. Now coming to direction. So direction is very important. So A matrix, so at node 1, A branch is outgoing, C branch is incoming and F branch also outgoing. So C is +1, A is outgoing -1, F is outgoing -1. So A is outgoing, so -1 and F is outgoing -1. Remaining, we have the C branch that is incoming +1. So just follow the rules. So at node 1, I have 3 branches. So write the values for 3 branches 1, 1, 1. After that, remaining branches are 0. Then go for the directions. So in the direction, which branch is outgoing? So outgoing branch direction is -1. Incoming branches are +1. That's it. Or coming to node 2. Node 2, how many branches we have? A, B and D. So A, B and D. Remaining are C, E, F is 0. Okay. So we don't have connected with node 2. Then A is incoming and B also incoming. So A is incoming, B is incoming, D is outgoing. So at D place we have the minus value. Remaining both are plus. Okay. So coming to node 3, at node 3, again how many branches we have? So 1, 2, 3 branches we have again. So at 3 branches, just write the values. So at B we have the value, and F we have the values, and E also we have the value. Remaining A, B, C are minus. A, B, C are minus. So A, C, D are minus. Now give the values. So here F is incoming, so plus 1, and B is outgoing. B is outgoing, we have the minus 1, and E is incoming. E is incoming means again plus 1. So F and E both are incoming, and B is outgoing. Outgoing means we'll get minus 1. Okay. So this is about like again node 4 we have one more node 4. Node 4. At node 4 how many branches we have? C, D and E. So C, D and E. Now check the like directions. So before going to direction, give the values. Remains are 0. Now C is outgoing. C is minus 1, and D is incoming plus 1, and E is outgoing minus 1. Okay, this is your A matrix. We will check it now in that we have already have the matrix here, A matrix. Now compare with that matrix. So at node 1 we have A, F, C. So A, F and C, we have 3 values and remaining are zeros. Now coming to directions, A is outgoing, F is outgoing, C is incoming. So C only positive, remaining A and F are negative. And coming to like node 2, at node 2 again A, D and B. So A, B, D, A, B, D. A is incoming, B is incoming, D is outgoing. A is positive, B is positive, D is negative. Remaining at 0. Okay. So and coming to node 3 we have same, and node 4 also same. Now if you want to find out the branch values, I said like between 2 nodes the sum is 0. So if you add this branch values, we'll get like 0. So negative, positive, negative, positive, negative, positive, negative, positive, positive, negative. So and negative, positive. So negative, positive, negative, positive means we'll get like 0. Okay. And here we have one more logic. Here one more logic we have. So in exam or any place we have n into B matrix. A matrix is n into B. So n is equal to 4 and B equal to 6. But he given only this matrix up to this. So here like he given like up to this. Up to this he given. So actually matrix is 4 into 6. Your A matrix is 4 into 6. Now he given only 3 into 6. He given 3 into 6. Then how will find out like 4th node values? So 4th node values is very simple. If we add like branch values, so here 0, minus 1 and 1. So actually branch values we need to get like 0. So we have the minus 1 and plus 1. So we have the 0 value. So we have no need to give the any value. Here also we have the positive and negative. So no need to give the like value here 0. And coming to C branch, we have the 1 value and 0, 0. We have 1, 0, 0, but we don't have any minus value. So we have 1 minus value at 4th node. We have 1 minus value at 4th node. And coming to like a D branch, again 0, minus 1, 0 is there. 0, minus 1, 0. So we have one more 1 value. And here 0, 0, 1 is there. But we have minus 1 value. And last we have minus 1, 0, 1. So minus 1, 1 is there. So no need to worry about that value 0. So in exam or any place, we have like 4 into 6 matrix. Generally A matrix is 4 into 6. But he given only 3 into 6 matrix. Then we need to find out the 4th node value also. So first node value, second node value, third node value he given. 4th node value we need to find out using this summation, branch summation. And And we have one more. If you know the A matrix, if you know he given the A matrix, okay, he given the A matrix. From this A matrix, we need to draw the graph also. That's also very simple. Okay, so how many nodes we have? 4 nodes. So just first mention the nodes 1, 2, 3, and 4 nodes. And at node 1 and 2, so A branch is node 1 and 2 we have. Okay, A branch is node 1 and 2. So 1, 2, 3, and 4. 1 and 2 I have like A branch, and B branch between 2 and 3. So B branch between 2 and 3 I have the B branch. And next C branch, that is 1 and 4. So C branch is between 1 and 4. And next D branch between minus 1 and, so that is 2 and 4. D branch between 2 and 4. And E branch between 3 and 4. So E branch between 3 and 4. And F branch between 1 and 3. So F branch between 1 and 3. Then give the directions. Here A branch 1 to node 2 to node 1. So why node 1 to node 2 means, so here node 2 value is plus. Node 2 value is plus. So we have the direction node 2. Here B branch at node 2 plus. So B branch also node 2 plus. And C branch node 1 plus. So C branch node 1 plus. And D branch node 4 plus. So D branch node 4 plus. And E branch node 3 plus. Node 3. And F branch node 3 again. So this is the if you compare both graphs, they are the same. So you can draw circuit to graph or matrices to graph also. If I have the A matrix, from the A matrix I can draw the graph. Okay, circuit to graph we know, but here if you know the A matrix, we can draw the graph also. Clear? And in the matrix A matrix, if you have like n into B, but he given like n minus 1 into B, he given n minus 1 into B. So here 4 into 6, but he given like 3 into 6. Then you can find out the fourth node value also. We need to find out fourth node value also using the summation of the branch values. Okay, so summation is not there, means if you have the negative value here we have the negative value, you can use the positive value. Here we have the positive value, you need to give the negative value. So like that. So circuit to graph or matrix to graph, both are same. We will get the same answer. Okay, this is about the A matrix, incident matrix. Now we are moving to B matrix, and B matrix is number of links into branches. So number of links into branches. So circuit we have the graph, but in that graph we need to go for the virginal graph. We require now trees and co-trees. So circuit to virginal graph to we require trees and co-trees. So we know how to draw the trees and co-trees, and the B matrix is number of links. So number of links means co-trees, not trees. Number of links means co-trees. So we have B matrix here, links into branches. That links is what's the value of links? So that is L equal to branches minus nodes plus 1. Okay, from the circuit to graph to virginal graph. In general A matrix, if you know like a circuit to graph, that is enough direction graph. Okay, but here we require the trees and co-trees. Okay, for B matrix we require that links, co-trees. Now, so here we have the circuit. So same circuit to graph we already discussed. From graph to virginal graph. Here graph to virginal graph, the trees are n minus 1. Trees are n minus 1. So n minus 1. And for this graph we have 4 nodes minus 1. So 3 trees. Remaining are links. Links also So for this graph, we have 3 trees and 3 links. You can draw your own wish. So we have like different types of trees you can draw. Okay, but we have conditions. Need to connect each node and should not in closed loop. For tree, if you want to draw the trees, so you need to use any 3 branches. The 3 branches are need to connect each node. So how many nodes we have? So each node, the trees are need to connect and should not in closed loop. So that is the rule for trees. And the links. Coming to links, we have the formula otherwise remaining. So which branches, remaining branches, those are the links. Okay. So from here we have C and D and E. So C, D, E branches. C, D, E branches are my trees and remaining are co-tree. If you observe the branch trees C, D, E, so connected to each node. So node 1, node 2, node 3 and node 4. So they connected to each node and not in closed loop. So this is my original graph now. So from this original graph, I want to draw the B matrix. And I draw the B matrix. For that, we require the links. So how many links we have here? A link, B link and F links. So these 3 are my links. So using these 3 links, I need to go for the B matrix. So before when I start the class, I said like B matrix is nothing but your mesh analysis. So like similar to mesh analysis. So mesh analysis means we need loops, number of loops. Clear? So number of loops. So here also I need to go for the number of loops. I need to go for the number of loops. That loop also we have the conditions. That loop also we have the condition. So you can use any loop. You can use any loop. Loop means it's a closed path. So if you started to one branch and closed with same branch. Okay. So if I started at 3, so A branch, that node 1 I started, and that is A, then B, then C. So A, D, C we have now. This is one closed loop. You can use like A, B, E and C. It's a closed loop. Okay. But which type of loops we need to use? Just observe guys. So here A and D and C. It's one closed loop. Okay. And you can use like A, D. So A, B, E and C. It's also closed loop. And if we are like A, F, this is also on closed loop. And this is also on closed loop. And this is also on closed loop. Okay. So which type of closed loop you need to use? Any conditions there? Yes, we have a condition. So you need to use how many links we have here. Links into branches. Your B matrix is number of links into branches. So how many links we have? 3 links and branches, 6 branches. So we have 3 into 6 matrix. So we have 3 links means we have 3 loops. So in this original graph, you need to use the each link and go for the closed loop. So if I use only one link, so here I have the A branch. So I need to use this A branch and need to close that loop. So using A to D, D to C. So this one my closed loop. So for this closed loop, I need to have only one link. So which link that is? A link. So here tree, here tree. I have only one link. So if we have one loop means, one link means, I require only one co-tree. I require only one co-tree. So we are going to closed loop. For closed loop, in the closed loop, I require only one link. Not more than one. So here, suppose my closed loop, I want to take like A and B. B is also co-tree. So no need to consider this is with close. Okay. Now we have A, D, C. It's a closed loop. Coming to B, also one tree. So using this co-tree, so B also on co-tree. So using this co-tree, I will go for the link. So this is my loop. So B, D and E. This is my closed loop. And coming to F also one link. So for this, this is my, so F, E and C. This is my loop. So we have the 3 loops. So 3 loops is depending upon 3 links. So that 3 links. So any loop, I need to consider only one link, remaining are trees. So only one code tree, remaining are trees. Now if you observe, I will show you one by one now. So this is my original graph. For this original graph, I want to use first one is F. F is my link. So using this F branch, I want to go for the closed path. So F then E and C. So F, E and C. So in this closed path, I have F is only one code tree. Remaining are trees. And what about A and B? A and B also, here A and B also your links. So code trees. Now here you need to use like only one. Coming to A, if suppose I want to use A, for A, this is my closed loop. This is my closed loop. So I need to use like A. Here I have only A. What about F and B? Both are not there. So no need to use both 2 values. And coming to B, it's my closed loop. It's my closed loop. Okay. So here also we have only one B link, here A link. And so for each loop, which branches you are considering. So for F is my code tree. So for this code tree, I will go for the loop. For this loop, and use like E branch and C branch. That's it. What about D branch? So I'm not using this D branch. Here I'm using like A, B and C. A, D, C. So 3. What about E? E is I'm not using. Only 3 branches I'm using. And coming to B branch, I'm using D and E. So D and E my trees. And B is your code tree. So I'm using only 3. What about C? C is like open. No need to consider. So each branch direction also now important. Now check it now. Here we have like a one loop, and which direction I need to follow. Here I have a loop. So this direction or this direction. So you need to use the link direction. So link is your F. So I need to use the F direction. And use the F. Which direction we have? F direction. Why F means F is your code tree. Here links into branch. So I need to use the links direction. So links direction is F direction. F direction is, this is my F direction. Compared to F direction, E is reverse and C is same. So F and C both are same, but E is reverse. And coming to A is my, so link 2, this is the link 1 and this is a link 3. So link 2, so loop 2, we have A and D and C. If you compare the direction, so A direction and B, D direction and C direction. So 3 are in same direction. And coming to loop 3, so B direction, D direction and E direction. So everything is same. So now give the values for B matrix. So loop 1, which we have a loop 1, F and E and C. So C, E, F. So which branch value we have connected for that loop. So you need to give the values. Then go for the direction. So remaining are 0. So not connected branches are 0. And direction. Direction is only E is reverse. So remaining are same. So only E is reverse. So we have the minus value. Okay. And coming to loop 2. At loop 2 we have A, D, C. So A, C, D. Positive values. Remaining are zeros. Why means 3 branches are connected loop same direction. So A direction, that loop direction is same for A, D and C. And loop 3, in that loop 3 also B direction, D direction, E direction. So 3 are same. So we have the 3. Okay, just observe the directions. Which direction we need to follow? That link direction. So that link, so in that branch, in that loop, and that like at node, your node started and ended with that same node. Now in that closed path, we have only one link. That link direction we need to follow. So like that, we have three links. So three links means matrix is 3 into 6. So here 3 into 6 matrix. And we need to give the values for each direction. So if you have the direction is reverse, we'll get the minus value. If you have the same direction with the positive value. Which branch is not connected, those are 0 values. Coming to one more matrix we have, that is C matrix. So that is cut set matrix. So instant matrix and tie set matrix. Now cut set matrix. So cut set matrix is very simple, but at instant matrix we have the nodes in that branch direction, and tie set matrix we have links, number of links how many we have, those loops into that branches. Now coming to tie set matrix, so cut set matrix, we have cuts. So where I need to cut the cuts, which node I need to cut. So that node is depending upon your trees. So for this circuit, we have the graph and graph to original graph. So graph to original graph, after that we know. Then we have trees. For this graph, we have 3 trees, that is C, D and E. These 3 are my trees. So we have C, D and E. Now B matrix, tie set matrix, we have to follow links. Now here we need to follow trees. So we need to cut any tree. We need to cut any one tree at any node. So here C is my tree. C is my tree. So I can cut. So connected between 1 and 4. Connected between 1 and 4. So I can cut the tree at node 1 or node C. Node 4. For C is my tree, am I right? So at C tree, I need to cut at particular node. So this is my node. So between 1 and 4, my C is connected. C branch is connected, that is tree is connected. Now I need to cut the tree. So I can cut at node 1 or node 4. Your wish. You can cut any place. There is no condition. But if you want to cut here at 4, again D also connected. So for D, we have only one chance, that is 2 node. And E also connected. For E also we have only one chance, that is 3 node. Okay. So again D also no need to cut here. Why means we already cut that C branch value. We already cut at C branch value. And if suppose. So for C branch, this is my cut at node 1. And then you can use like a D branch. You can cut here. So no need to go for this. And E branch, we need to cut here. Why means here already we use like for D branch. So for tree, you can cut any place. But you need to cut that tree. If you have the tree, then only you need to cut. If you don't have any tree in that node, that's not possible. Why means each node need to connect the trees. So trees are connected to each node. That's the rule. So you can use any node. You can use any node and cut the tree. That's it. So for simplify purpose, I have like 3 trees here. So C, D, E. So I need to use like 1 node, 2 node and 3 node. So 1 and 2 and 3. So I have this is for C branch, C tree, and this is for D tree, and this is for E tree. Now check the directions. Now C is incoming. C is incoming to node 1. So incomings are you need to consider like positives. And remaining unconnected nodes are 0. Unconnected branches are 0. Now coming to B, it's like outgoings. So outgoings currents are positive. And coming to E, again incoming currents are positive. Okay, now just go for the C matrix. So C matrix, that is a number of cuts. So how many trees we have? 3 trees. So for 3 trees, we have 3 cuts. So C1, C2, C3. So C1, C2, C3. So C1 for like one branch, one tree, that is C tree, and C2 for D tree, and C3 for E tree. Now C1 incoming currents are positive. Why incoming? So your branch C is incoming. So for C1, C and A and F. So C, A, F, three are connected, but C is only incoming and A and F are outgoing. So A and F are outgoing, so minus 1s. And coming to like this node 2, so cut 2, C2, outgoings are positive. So it's C2 outgoings. So D is outgoing, A is incoming, B is incoming. So A is minus 1, B is minus 1, D is outgoing, positive. Remaining are 0. So not connected branches are 0. Then coming to C, C3, E branch incoming. So incomings are positive. So E is incoming, but B is outgoing and F is incoming. So B is minus 1, E and F are positive. Remaining are 0. So just observe guys, where we need to cut that tree value. Suppose my cut is here for C. For C, my cut is at 4th node. Then you need to go for the outgoings are. Outgoings are positive. So C is outgoing. So I'm using the C. That is my C1. So I'm using the C branch tree. So that is my first cut. Now outgoings are positive. So then C and D and E. You need to use like 3 values. So here C is outgoing, E is outgoing, B is incoming. So C's we have like a positive and B is minus 1 and A is plus 1. So you can say like values are different. Yes, values are different only. But at last the answer is same. Which answer? So for using cut-set matrix, we need to use the node voltages. Node voltages and across the branch, across voltages. Same thing, Tyson matrix, you can find out the branch currents, loop currents. You can find out the branch currents and loop currents. Okay, this is about like a small introduction about ABC matrix, and next class we'll go over a small problem on ABC matrix and find out how we'll get the loop currents and branch currents, as well as node voltages and branch voltages. If any queries, contact me in comment box. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.